This is section 6.2, the law of cosines. Objectives. Again, you can pause to read, but I'm moving on. Vocabulary key concepts. We're still going to be working with oblique triangles, Heron's error formula, and also for the law of cosines, these are the cases that we're going to be dealing with: side, 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 and side angle side. Here we go. These are the formulas. This is the law of cosines. And notice that you have two forms. You have the standard form and the alternative form. You're going to have to memorize these formulas. Notice that we can generate, if you memorize this formula, you can generate this formula by basically solving this equation for cosine of angle A. And you end up with this. And technically, you only have to memorize one formula because all the other ones follow the same idea. The only thing that changes is the letters. Okay, moving on to the next slide. So here it says use the law of cosines to solve the triangle. Notice that you're given side, side, side. So I'm going to first find angle A. So I'm going to plug in the values into this formula. And this is what I get. At this point, you punch this into your calc, and you end up with something like this. And then at this point, if you want to find angle A, you have to use the inverse function, and that's how you end up with 20.7 degrees. Then I'm going to find another angle, cosine C, but first I'm going to substitute the values into this formula now, since I'm looking for angle C. I get the following. This is the decimal approximation that I get, and then I find the angle by using the inverse function, and this is what I get. To find angle B, all I need to do is 180 minus the sum of A and C. So here's my answer to number 1. Moving on to number 2. Same directions. So now I'm looking at an angle side and an angle. Notice that this is side, angle, side. Moving on to the formula. So then I am going to find little b by using that formula you saw earlier. I substitute the information into the formula. This is what I get. I punch this into the calculator, and I get this number. And then at this point, notice that this is b squared. So to find b, I need to take the square root of this, and this is what I get, approximately 10.53. And round to the nearest 100. Then find angle C. I use the formula you saw in the previous problem number 1. Substitute the values. This is what I get. Notice that I have 10.53 squared. I get the following. Since I want to find angle C, I have to use the inverse function. And I end up with 37.6 degrees. At this point, I'm left. All I have to do is find angle A. And this is how I can find angle A. And then I write the information that I found on problem number 2, and here it is. Moving on to number 3. This is Heron's formula, and this is the formula that you could use to find the area of any triangle by knowing just the side lengths. So the formula is right here. You're going to have to memorize it. Area, and notice that you have the square root of whatever this is. Notice that S is the sum of all 3 sides divided by 2. It's not the average, it's not divided by 3, it's just the sum divided by 2. And then A, B, and C, whatever those dimensions are in the triangle. So let's apply this. It says use the formula. You're given that A, B, and C are those sides, those dimensions. So then we first find S equals 46. Then I apply the formula, area equals. Here it is. So instead of writing S, I'm going to write 46. And then I'm going to write for A, B, and C what was given. I punch this into the calc. Or actually, I can simplify it a little bit more. This is what I get. Then I take the square root of this and around to the nearest tenth. And the answer is 385.7 square units. Here's number 4. Word problem says to approximate the length of a marsh, a surveyor walks 380 meters from point A to point B. Then the surveyor turns 80 degrees and walks 240 meters to point C. Approximate the length of the marsh. So this is the picture that goes with this, the information in the problem. You should be able to generate this. Shouldn't be too complicated. But so let's continue. To approximate the length of the marsh, which is this distance. First, I'm going to find out what this angle is, which is 100 degrees. I'm going to call this little b because it's opposite to angle B. I am going to apply. I have enough information for me to apply the law of cosines. To apply the law of cosines. So I'm going to substitute the information in here. This is what I get. I plug that into my calculator. I get the following. At this point, I don't want b squared, I want b, so I take the square root of this, and this is what I get, 483.4 meters. Number 5. This is another word problem. This is the picture that goes with number 5. So it says a 100-foot vertical tower is to be erected on the side of a hill that makes 6-degree angle with the horizontal. Here's a 6 degrees with the horizontal. Find the length of each of the 2 guy wires that will be anchored 75 feet uphill and downhill from the base of the tower. So you're looking for these 2 wires that are called guy wires. So first what I'm going to do is I'm going to find this angle, which is 6 degrees. Why? Because these 2, the horizontal here and this horizontal here, are parallel, and this is a transversal, so these are alternating triangles. Then I know that this angle here is 96. Why? Because this is 90 degrees, and this needs to be erected perpendicular to a horizontal, not the side of the hill. Otherwise, we have problems, it'll fall. So if this is 90 and then this portion is 6, so it's 96. Now this other angle is 84 because they form a linear pair. Now this is what we're looking for. Wire 1, wire 2. So let's find wire 1. So notice that this is 75, this is given, this is 100. We know this angle. So then I plug this into the formula for law of cosines. I simplify this. I get the following. I don't want W1 squared, I want just W1. And this is what I get. 131.1 feet. And in the same manner, I'm going to find W sub 2. Just to different some, I'm going to be using different values, but you should be able to follow where they come from. Going kind of fast here. And then at the end, this is the length of wire 2, 118.6 feet. And notice it makes sense that this is shorter than the first wire. Number 6, and this is the last one. And this is for fun. You should be able to follow though. It's going to be challenging, but don't give up. Don't be a quitter. Persevere through this problem. Okay, so what I'm going to do is I'm going to make sure that one side is equal to the other side, so I'm going to work on the left side. Using the law of cosines, I can write the following. This is just that. Everything else is here. Now I wrote brackets instead of the parentheses you see there. Then I want to have the same denominator, so I multiply this top and bottom by 2bc, and this is what I get. Now that I have the same denominator, this is what I have. And I move some things around, and I also actually, what did I do? I just cancel the BC, 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 and everything stays the same. Another thing that I forgot to highlight, notice that I'm distributing this negative here, and that's how I get negative b squared, negative c squared, and positive a squared. And then at this point, let me go up here. This is where I move some things around. I move the a to the front, negative b squared. I put the 2bc in the middle, and then negative c squared at the end. Why did I do that? Because I'm going somewhere with this, and notice that I have a first on the right hand side. Now at this point, I notice that I have a trinomial here, and what I'm going to do is I'm going to pull out a negative. If I pull out a negative out of this trinomial, this is what I get. At this point, you should be able to see that this is a perfect square. This trinomial becomes b minus c squared. I bring down the sign. Bring down the a squared, bring down the 1/4. At this point, I'm going to go to the next slide. Here we go. Continuing with number 6. Again, this is where we left off on the previous slide. So now what I do, I factor this. This is like, I don't know, a squared minus b squared. This is the same thing as a plus b, a minus b. And that's what I have over here. I included brackets and parentheses, but you should be able to follow. Now at this point, this is what I'm going to do. Nothing really happens here. I distribute the negative into this binomial here. This is what I get. And the 4 now is in the bottom of this product. Next, I get rid of the brackets. And now it looks like this. The 4 becomes 2 times 2. Then I'm very close to what I wanted to equal on the right hand side. But notice that this is on the left hand side and this is on the right hand side. So I just switch it around. Give each numerator its own denominator, and then we are done. Fun problem. This is the end of this video.